Right. So in our previous lecture, so I discussed already about the staffing, right? So initially, the staffing pattern required for a particular, R&D sort of projects um, has been, developed by Norden, and to the Norden's work. By taking Norden's work, so Putnam extended further by studying the same staffing pattern problem, for software projects, right? So, as we discussed, like first once the effort is estimated, and thereafter, uh, we need to we need to go for the staffing requirements. So Nodal source, he usually studied by using R&D type projects. So the characteristics of this R&D type of project is completely different from maybe sales outlet sort of projects, or maybe the software kind of projects. Okay. So according to Norden, so the staffing pattern can be approximated by the Rayleigh distribution curve, right? So initially, you will have very few number of persons or the developers at any point of time, and slowly, at some point of time, you will see there is a more number of developers employed, and thereafter slowly this the number of the developers gradually decreases over time. Okay, so this is one of the requirements. So this notals works only applicable to R&D projects. So now the Putnam. So I stopped here at this point of time, right? So now the Putnam studied the problem of staffing of software projects and found that the staffing pattern for software projects has characteristics very similar to other R&D projects. So he says, so now software projects also have very similar characteristics with the R&D type of projects. Okay, but small number of developers at the planning and specification tasks. Okay, usually we also, as I told you before, so at the beginning of the R&D project, so you deploy very few number of people, we require very few number of people. Similarly, in our software projects also, you have seen, right, during the planning or the requirement specification. So usually we have recruited or we require only few number of people, developers, right? So as the project progresses and more detailed work is performed, right? When we going towards design and coding, usually, so we require more number of developers. Okay, and we have seen so usually, so during product testing and all, you require more number of people, right? So and thereafter the number will be slowly decreased once it is deployed. So during deployment, so usually you will have very few number of people, right? So after implementation and unit testing, so the number of staffs falls. That is what after the testing, when during the deployment, so usually you require very few number of people, right? So Rayleigh Norton curve can be adapted, okay, to relate the number of delivered lines of code to the effort and the time required to develop the product. So here also, because this sort of characteristics, almost much of the characteristics have very similar with respect to similar with the R&D sort of projects. So because of which we can say, so the number of lines of code to effort, okay, whatever the estimations using this Rayleigh can also be adopted. So by Putnam, so after analyzing large number of defense projects, okay, so Putnam actually derived this following expression, okay. So that means L is equal to Ck k to the power of 1 by 3 Td to the power of 4 by 3, where k is the total effort required or put in or given total number of effort given in person months in a particular product type. So he has gone through various projects. So from the project itself, so they found, okay, so this is the total effort actually expended. Okay, so L is the product size, so that is in KLOC. So okay, so and TD corresponds to the system and integration testing time. Okay, the time that is required or spent on system and integration testing. Okay, so by taking these parameters, okay, so Putnam derived the expression, okay, that is L is equal to Ck k to the power of 1 by 3 Td to the power of 4 by 3. Okay, now so here there is a constant called Ck. We'll talk about that, okay, in the next slide. So you understand K is the effort, okay, and Td is the actual time taken for system and integration testing. Okay, then you can get this product size. Okay, now Ck, so usually it refers to the state of the technology. Okay, so I mean what sort of technology that we are going to use. Okay, so based upon if at all any constraints are there, so that will that actually obstructs the progress of the programmer. Okay, so that means you can think of like this. Okay, if Ck is equal to 2, value 2 is given, right, for poor development environment where we have not considered any methodology, okay, for the developments, nor we maintain any documentation, even we do not carry any sort of reviews. That means we are not applying any software engineering principles at all. Okay, so in that case usually the Ck value will be 2. Okay, so if you are not going through any development, proper development environment, what will happen? Usually the programmer who are actually going to develop the code for your software, so they face lot of difficulty, right? So Ck is equal to 8 means for good software development environment. If you are following all software engineering principles, that means we are going through a appropriate methodology. We are creating documentations, right? We have progress reviews, right? So whatever the principles that are there we studied in software engineering, so they are all applying. Okay, so if they apply, so in that case it will be very easy for the programmer, right? So that is the reason why so Ck will be more. Okay, so the value is given as 8. Okay, and Ck is equal to 11 for excellent environment. That means we apply the software engineering principle. That means we have gone through proper methodology, documentation, reviews, everything, whatever along with that we have used many automated tools and techniques. So then in that case, so the programmer who is going to develop the software, for him the job is very quite easy, right? So that as a result, so the Ck is equal to 11. So more value is given to that constant, but the exact value of this Ck, for a particular specific project can be computed from the historical data if at all available. Okay, so let's say in the past we have similar sort of projects. Okay, so then by studying those projects, now you can define this Ck, the value, you can get these values, constants, right? So those exact value can be computed. Now, so according to Putnam suggested that optimal staff build-up on a project should follow the rally curve. So according to Putnam also, so the build-up of the staffs, that means so the way that you recruit the staff, so that should follow a rally curve. That means initially, so you will be recruiting few people, okay, and slowly, you keep increasing the staff, right? And at some point of time, you will reach the peak, and thereafter again this, the staff, and there should be a fall in the number of staffs. Okay, so this is what a rally curve says, right? So you should also follow, right? So that would be probably the optimal staff build up. So that means this is the way that if you recruit, then that would be the better, or it is the optimal way, or it is the optimal way that we should follow. We should recruit the people, right? So for efficient resource utilization as well as project completion over optimal duration, starting from a smaller number of developers, there should be a staff build up, and after a peak size is being achieved, the staff reduction is required. So this is what exactly I explained to you, right? So if you recruit this way, probably you will be able to efficiently utilize your resources. Otherwise, you will not be able to utilize your resources properly. You can think of like this. Okay, so during requirement analysis, let's say you have recruited almost whatever the number of staff that you want, okay, throughout the project. So then what will happen? So they will be kept idle, they will be sitting idle, they will not be doing anything, okay, because only so analyst or one or two developers, so they will be part of this whole process, right? I mean requirement phases, the others will be sitting idle. As a result, what will happen? So actually we are wasting our resource, human resource. Instead, if we distribute these resources over the time, then probably we are going to efficiently or optimally utilize the resources, right? So the staff build up should not be carried out in a large installments. That is what I say. Okay, so I mean, so you should not recruit like this. At one point of time, you recruit more number of people. If you're doing that, probably you're wasting the resources. So team size should either be increased or decreased slowly whenever required to match the rally curve node, so that this team can be slowly increased. Okay, so maybe over the time you should keep on increasing the number, but that should also follow a rally curve, not a curve. That is what we have discussed. Okay, so experience reports that a very rapid buildup of project staff anytime during the project development correlates with schedule slippage. So people are saying that based upon the experience. So it says that if you rapidly build up the project staffs at any point of time, probably you will be going to see the schedule slippage. That means we are not going to meet deadline at some point of time. Okay, so you can think of something like this. Okay, so maybe it will happen like this. Okay, so during design phase you require maybe 1,000 people, right? But you have not recruited 1,000, you have recruited 500 people. But during testing, you have recruited 1,000, but required is 500. What will happen? So actually, we are not managing the staffs properly, right? So as a result, what will happen? We will not be able to, definitely we are not able to meet that deadline. Whatever the number really required at any point of time, those many number of people should be recruited, then it will be better, I think. Okay, this is what it all says, right? So some phases would be overstated and other phases may be understaffed. Okay, sorry, overstaffed and understaffed. That is what I explained to you. Okay, so causing inefficient use of manpower, leading to schedule slippage and increase in cost also as well as. Okay. So as per rally curve, if you see, if you see that particular curve, okay, so to the left of the TD, so that actually covers 40% of area, and to the right of TD, so actually that covers 60% of the area. Okay, so from these things you can easily understand. So it all implies that the effort required to develop to its maintenance effort is approximately 40 and 60. So we have seen in the past, right? So I told you very beginning. So you require 40% of effort required for the development phase. Okay, 60% for the maintenance phase, right? So this is what exactly a rally curve is also representing, right? So the 40% of area to the left of TD, that corresponds to the development phases, right? And the rest 60% actually that attributed to your maintenance phase. Okay. So now, we try to study when you change the schedule, okay, how the cost actually vary. Okay, so we try to study from this Putnam's equation only. So there is a rearrangement to the equation, right? So we have seen that L is equal to k to the power of 1 by 3. Okay, and then so this sort of equation we have seen, right? L is equal to k to the power of 1 by 3, and then ck and td to the power of 4 by 3. This is what the equation we have seen in the past, right? So that was the expression derived by Putnam. So now by rearranging, so we get this equation k is equal to L3 by ck to the power 3 td to the power 4. Okay, now further you can see, so L3 by ck to the power of 3, that can be kept as a constant. Okay, that can be kept as a constant. Okay, and now you can think of, so where L is what? L is the number of lines of code. Okay, and ck is the environment attributed to the kind of development environment we are using, right? So now that can be constant. Let's say assume that, so we have similar sort of product. Okay, we have the same product size. Okay, so then this value will be definitely constant. Okay, so now because A has a 1000 number of A product has 1000, A software product has 1000 lines of code. B software product also 1000 lines of code. Okay, now we assume that CK, the environment, is also used by both the software developments. Okay, for both the software developments is the same. So in that case, then we can assume that C is equal to L3 by CK can be as a constant. Okay, then now what you can get? So now for then only the variables here are, so K and TD, right? So K is actually the effort. Okay, K here is actually the effort, and TD is actually the time. Okay, so the time. Okay, the time that is attributed to the system and system and integration testing time, right? Now what I'm trying to say, what we are trying to find from this, so we try to find a relationship. So K is indirectly proportional to TD. K is indirectly proportional to TD. Okay, now what we are trying to say, let's say for example, so the development duration you want is 6 months initially. Okay, for which maybe the cost effort will be something, maybe 100% months or something like that. Okay, 6 months or 1 year, 100% months. Okay, this may be initially. Okay, but now after some time, so the management says that you need to reduce the development time. That means they want the development should be done within 6 months instead of 1 year. Instead of 1 year, they want the development should be done within 6 months. That means what happened? Now you halve the development time. You halve the development time. When you halve the development time, so what is happening? That means previously you require only 100% months in order to complete that project within 1 year. Okay, today there is a requirement like this. No, we want that project should be delivered, or we want that particular project within 6 months. That means the duration is halved. Okay, so then what will happen? Whether the effort you really require, the will be more or less? Can anyone tell me? If the development time, if you
More.
reduce, if you want to reduce, then the effort will be required will be more or less? Anyone?
More. More.
Why you require more?
Because time is reduced, but the work to be done remains same.
Yes. So then you want many people should work, right? I mean, so you can think of like this, okay? So you wanted to develop the project in 1 year, okay? So now suddenly your senior says, you need to complete that project within 6 months. So then what you will be going to do? You will have to sacrifice few nights, okay? I mean, you have to work day and night so as to finish that particular task project, okay? So that means, so you require more effort, right? So if you wanted to deliver, right? But now this from this particular equation, so k is indirectly proportional to fourth power of td. You understand? T to the power of 4. Okay, that means, so I mean, if you're going to half the duration, so probably how many times the cost will be increased? If you're going to half the duration, how many times the cost is going to increase?
Twice.
Twice. Why twice?
So because in the equation k equal to L power 3 by ck power 3 td power 3, if we put t equals to 1 in the first case and in the second case half, then the 2 comes to the numerator, and in whole it becomes twice of the previous case.
Array, you assume like this, okay? So I said you k1 by k2, okay? So initially k1 was k1, and maybe you think of like this, okay? Initially you have a k1, okay? Now the time initially, we required is, let's say t only, okay? T time. Now what I'm saying? Now t2 will be raised halved. That means instead of t, that will be t by 2. Okay. Now you substitute. Okay. T to t t. You can understand now. Okay. So by substituting this t, so how many times it will increase? T क्रॉस हो
60
जाएगा.
times.
इट्स a very simple things. फिजिक्स में नहीं किया था क्या प्रॉब्लम? P1 V1 is equal to constant. वो प्रॉब्लम नहीं किया था उसको. So if you say the TD, initially you have the TD is equal to T, and thereafter the TD becomes T by 2. Okay, क्या होगा? How many times the cost will increase or the effort will increase here? अरे 2 to the power 4 man, T to the power of 4 and by T to the power of 4 by 2. Okay. So then what will happen? T to the power of 4 and T to the power of 4 will be cancelled out, and 2 to the power of 4 will be going up. So that means it will be 16 times. It's a simple mathematics. Don't understand? Now got it or not?
Yes, sir.
Yes, sir.
How many of you got this? All?
Yes, sir.
Okay.
Yes, sir.
So it is a 16 times. Okay. So because of just halving your schedule, so now the cost is increasing 16 times. Okay, now you can understand. Okay, so this is the way that if you want to reduce little delay, I mean you wanted to compress the schedule by a smaller quantity, now your cost will increase exponentially. That means by the power 4. Okay, in terms of 4. Okay, so that means, so you should be very careful about this. Okay, so that is what we say. So why does project cost increases? I mean, you see, effort is increased, so then automatically cost will also increase. You know that, okay? So that is the reason why. So usually cost increases. So why does the project cost increases when schedule is compressed? So this is what exactly. So now, when yes, it is true. So the project cost, the effort will be increased by 16 times. Okay, if you just simply half the schedule, right? Then your cost is also increasing in that proportion. Okay, so then extra effort can be attributed to the idle times of the developers waiting for work. You see, so you compress the schedule. Okay, you compress the schedule, right? When you compress the schedule, so what it assumes that, probably, so the people, so there were some idle times. Okay, because 1 year means what, there may be definitely some idle times. That means unless or until some activities are carried out, other activities cannot be started. Okay, as a result, few people are kept on waiting. Okay, so until or unless coding phase, design phase is completed, so the coders are waiting, right? Now what is happening when you compress the schedule, so you may be, these coders may be, given some other task, or they can be, so something like, you have to do some parallel activities, right? So that is what it all says. So extra effort can be attributed to the idle times of the developers waiting for the work, right? So managers recruit large number to complete the project early, but difficult to keep them occupied with work. Okay, so usually, whenever you wanted to compress the schedule, that means you wanted to, you want that particular software will be delivered within 6 months instead of 1 year, right? Definitely, so you need to recruit more number of people so as to complete that particular task, because you require more effort. Okay, so that can be only solved by recruiting more number of people, right? So implicit fact according to COCOMO that all developers can be continuously assigned work. So it is a fact according to the COCOMO. What it assumes is, so each and every people, so they will be continuously given some work. Okay, this is what the assumption, right? So they are doing some activity at any point of time. Okay, so they are not kept idle. So this can be, you can thought of, right? So activities in the project which can be carried out simultaneously are restricted, right? So but according to COCOMO, what it says, so we cannot carry out many activities simultaneously. That is what restricted by the COCOMO model, right? So as a result, what will happen? As a result, so these fewer number of people only will be working for a longer amount of time. Okay, because some of these activities cannot be carried out simultaneously. Okay, so that means, so coding and design, they cannot be carried out at the same time. Okay, so once the coding design is completed, then only we can go into coding, right? So everything cannot be, you cannot parallelly do something, right? Only what you can do is, maybe the coder can be asked to do some design activity. Okay, so that way you can think of. Okay, so that can be possible, or you can recruit few new people for this particular project. Okay, so that means, right, so what happens that, let's say if those are the people only going to do the design, going to do the coding, going to do the testing, then it's fine. Okay, so those few people only will be kept occupied all the time. Okay, so first they will finish that design part, and then coming to the coding part, then they will be going into the something else. Okay, so that can be allowed. Okay, now Putnam's model indicates an extreme manpower penalty for schedule compression. Okay, so an extreme reward for expanding the schedule. Okay, so now you can understand, right? So according to this Putnam model, what it says, so if you try to compress a lot, okay, definitely the effort you require is more. Okay, that means you require more manpower. As a result, the cost will be the cost will be more. Okay, because it is the 4 times, I mean 16 times, just by halving the schedule, so you require 16 times. Okay, so the effort is increased. Okay, so now you can understand. So the compression actually leads to extreme manpower penalty. Okay, that means you require more manpower, right? So that is what in terms of, you can think of manpower penalty. Okay, so an extreme reward for expanding the schedule. Now if you expand the schedule, probably you will not get that sort of penalty, right? So whatever, you know so instead of 1 year, if you say ki we wanted to develop that particular solution, or the software within 2 years, then what will happen? So usually you will not be going to see any increased cost. Why? Because the manpower, we will not going to see this, manpower penalty. Okay. So the Putnam estimation model works reasonably well for very large systems, but seriously overestimates the required effort on medium and small systems. So it says, so this is applicable only to very large software systems, but for small software systems, so usually, so this is not giving an accurate estimations, rather it is overestimates. Okay, rather it overestimates, right? So Boehm states that there is a limit beyond by which the software project cannot reduce by its schedule by buying or any more personnel or equipment. So Boehm says, so you cannot reduce, to whatever the extent you want. It is not like that. Okay, so there is always a limit, right? So I mean, as I said you, so if the project should be developed in 1 year, instead of that you can reduce it to maybe 8 months or 6 months, but you cannot reduce it to 1 month. Okay, why? Even if you buy, even if you have more human resources, technical people, even if you have more equipment, still you cannot reduce. Why you cannot reduce to whatever the extent we want? Can anyone tell me? Any student here, can you tell me what is the reason why you cannot reduce to whatever the time, within that time you want to have that particular software?
Sir, because some processes take place sequentially. Hello?
Yes.
Some processes take place sequentially.
Can you loudly speak?
Some processes takes place sequentially, like one after another. So they
Right.
will.
Right. So here the sub process means which one you are talking about?
Uh, uh, sir, sir, like in the development phase, like when we are coding, then there are some
Right.
functions
So
that
that
should be
means,
made.
so already yes. So Mohammed Rikaz, you are absolutely right. Okay. So that means, so you cannot execute, or you cannot carry out all of the activity of software development parallelly. Okay, if you can carry out all of the activities parallelly, then it is fine. Okay, you can reduce to whatever the time you want. Okay, but so we are going through the software engineering principles. That means, so there are certain things like, so unless or until you finish this requirement analysis, you cannot go into the design phase. Okay, or unless or until the high level design is not finished, so you cannot go into the detailed design, right? So there is a always a dependency, right? So we can reduce by a certain amount, right? Like within that particular activity, let's say design phase, we can parallel, you can carry out certain number of activities parallelly, but you cannot carry out parallelly design as well as coding all together. Okay, so that is the reason why. So Boehm says that you can limit, that particular reduce, I mean the. So if you want to compress the schedule, so you can compress up to certain extent, but not to the limit whatever you want. Okay, I mean whatever the duration you want, it is not possible. Okay, even if you have a more number of resources, equipments, so still you will not be able to do that. Okay, so that is what it says. Okay, so now this limit occurs roughly at 75% of nominal time estimate for small and medium sized projects. Okay, so usually it says according to Boehm, for the small and medium sized project you can compress the development time. You can compress that particular schedule by 75%. Okay, up to I mean till 75%, not. Okay, so the complex development time by more than 25% unlikely to succeed. Okay, if you say that if you want to compress by more than 30%, something like this, you trying to reduce that. Okay, so if you, as I said you in my example, so if you half the development time you want to compress by 50%, that means you are halving the duration, right? So if you compress by 50%, in that case definitely you are not going to succeed. You are not going to succeed, that means you are not going to deliver the product. Okay, so every project has only limited amount of activities which can be carried out simultaneously, and sequence activities cannot be speeded up by hiring more. Okay, so that means still you should be able to only a few activities which can be carried out parallelly, right? So now, so it is very similar to Putnam's model. So Jensen also proposed a model. Okay, so he also developed a model. So that is actually meant for smaller and medium sized projects, not for the large projects. Okay, so your Putnam's work was completely targeting the large projects, but it was not possible for the small sized project or mid sized projects because it overestimates. Okay, so thereby, so Jensen has come with an expression for small and medium sized projects. Okay, so usually it attempts to soften the effect of schedule compression. Okay, so because in case of small projects, maybe you will be able to you can compress that particular schedule to a large extent as compared to large projects. Okay, so now the Jensen's equation is something like this. Okay, so CTD k to the power 1 by 2 is equal to L. So you know this, what is TD, and you know. Yeah, Subra Sarkar, can you please mute yourself, Subra Sarkar? Okay. So this is what exactly here CT is also a constant, that is the effective technology constant, that is similar to the previously we have seen, right? And TD is the time to develop the software. Okay, so K is the effort required to develop the software. Now this says, according to his equation for the small and large medium scale projects, so now the effort is indirectly proportional to square of the TD. Okay, square of the TD. Okay, the where where CTE and L is assumed to be constant. So now, so if you have the schedule for a small project, if you have the schedule by six months instead of 1 year, so in that case, what will happen? So it will be 4 times. The cost will be increased by 4 times, not by 16 times. Okay. So this is what it all says. Okay. Any doubts so far, students?
No, sir.
No, sir.
Okay. So here we ends up with this staffing. So we'll be going into the other topic called as scheduling. So we'll talk about scheduling also a little bit today. Can you see the slides? Any student,
Yes,
can you
sir.
tell me?
Yes, sir. Yes, sir. Scheduling
Okay.
slides are visible.
Okay. So as I told you before also, right, once the effort is estimated, right, and thereafter you can plan the scheduling, right? So scheduling is also one of the very important activity for all these project managers, right? So because they have to schedule different sort of tasks, okay? That means like they need to find out what are the different tasks of a particular activity, okay, and then these tasks should be given some deadline, right, by this month, and so this particular task should be finished, okay, by the next month, so the other task should be finished, right. This sort of scheduling should be done, right. Once if this scheduling is done, accordingly you can plan the resources also, right. So for that particular task, whatever the resources that you want, so you can plan them, right. So the scheduling problem in essence consists of deciding which task would be taken up when and by whom, okay. So usually, so by what time this task should be finished, or at what time point of time this task should start, and as well as who are the ones involved in this particular task, okay. So those things can be planned, okay. So that is what exactly we say scheduling. So once a schedule has been worked out and the project gets underway, the project manager monitor the timely completion of this task, okay. That is what I say to you, okay. So this will help you in monitoring the progress of the project development, right. So whether we are up to that deadlines or not, whether we are whether we carry out that activities as per as per uh, as per the time defined, okay. So this is the way that so it takes any corrective action that may be necessary, okay, right. So that means if at all if at all any difficulties that we face during a particular task, so in that case we need to take some corrective actions there itself, right. Otherwise what will happen, so that may lead to schedule slippage. That means we will not be able to deliver the software in time, okay. So it will help us for help us in monitoring the progress of the project, okay. So this way the scheduling is much more helpful, right. So job of a project manager to schedule project activities, right. So this is so part of certain activities, so we'll be going to discuss, right. So these are the certain activities a project manager can take up, right. So identify all the major activities that need to be carried out to complete the project. So the first thing that project manager does is, so he try to find out all the major activities, right. So once these major activities are identified, now then these major activities are broken down or break down into various tasks. Okay, now after breaking down into different tasks, okay, so you can think of so activities are you can think of it's a you know bigger job than a task. Okay, so you can think of, right? So now, so you can think of like this. So you have a activity like design phase is one activity, right? So now for that design activity will be divided into some tasks, right? And then these tasks will be scheduled, maybe, so unless or until few tasks are carried out, so the other set of tasks cannot be started. That means, so there you can have some sort of dependency also. Okay, so determine the dependency among different tasks. Okay, so that means which task should be finished fast. Okay, which task should be started after this task. Okay, this sort of thing, right? So you need to find out the dependency among them, right? Then establish the estimates for time duration necessary to complete the task. So then you will be estimating, so how much time you really required, for each and every task. Okay, so then represent the information in the form of an activity network. Okay, so then we present all of this information in the form of a activity network. We will talk about that, what is a activity network later on. Okay, so as of now you understand. So these are the things. First thing, that we try to identify the major activities, and then we try to break down these major activities into tasks, and then we will try to find out the dependency among these tasks, and then you need to estimate the time durations that are really required. I mean, time durations required to complete that particular task. Okay, and then all of these informations will be provided in the form of a activity network. This is what actually carried out by a project manager. Okay, and then determine task starting and ending dates for the information represented in the activity network. So there also you will be saying that, what time this task should start and by what time this task should complete. Okay, by what date this particular task should be completed. Okay, so this sort of starting and ending dates will also be provided, okay, in the activity network. Okay, determine the critical path. Critical path is the chain of tasks that determines the duration of the project. Okay, so now, so after getting a particular network, so you can think of it's a graph. Okay, so then you try to find out a critical path. So that critical path will tell you that, that is so will tell you that it is the, I mean, minimum time required to finish or the complete all of the tasks, okay, of a particular project. Okay, so that means, so that is what exactly the duration it will tell you. So when you find out the critical path. Okay, so and accordingly, so you allocate resources to those tasks. Okay, once you found that critical path, okay, now by following that particular critical path you assign the resources. Okay, so we'll talk about that, how to find the critical path and all. So we will see in later, so maybe in the after few slides. Okay, so the first step in scheduling software project involves identifying all activities. Okay, and sometimes, a project manager, with good knowledge of the various complexities of the project, okay, and better understanding of these development processes, which will help in identifying these major activities or the important activities of the project. Okay, so it all depends upon the project manager, because he is the one exactly going to identify the activities. Okay, so the activities are broken down into a logical set of smaller activities or the tasks. That is what I said you. The smallest activities are called tasks. Okay, so usually, what you do is, so first the large activities will be divided into, sub activities, and these sub activities may be further divided into sub activities. Okay, so you keep on dividing these activities. We are going into a very fine level where that activity is called as a task. Okay, and it is assigned to this task is assigned to a particular developer. Okay, so maybe we have smallest activities, so these activities will be given to different developers, right? The smallest unit of work activities that are subject to management planning control are called tasks. Okay, so that means, so these are the very smallest unit of work. Okay, and this can be, this can be managed, and it can be monitored, and it can be controlled. That means let's say it may last 1 or 2 weeks. Okay, so the duration of this task may be 1 or 2 weeks, and if you are facing any difficulty, so that can be controlled. Okay, that means you can take certain corrective actions so as to bring the development onto the track. Okay, so this way you can think of. So a project manager breaks down the task systematically by using work breakdown structure technique. So we will talk about a work breakdown structure technique. So by which actually, by using that, we try to break down the task. I mean, break down the whole activity into the large activity into a certain number of tasks, right? So after the project manager has broken down the activities in tasks, he has to find a dependency among the tasks. So, and then also we need to find out what the dependency relationships that exist between the tasks should be developed. So the dependency among different tasks determines the order in which different tasks will be carried out. That is what. So it is actually telling you the order, right? If let's say if there are two tasks, okay, so you can think of something like this. So if you want to start a task A, and that task actually requires the results of another task B, then in that case what? A is dependent on B. That means first B should be carried out, okay, and then only the A task should start. Okay, so this may so you can think of, so that means A is dependent on B. Okay, so now, so you can see in general actually what we are trying to say in a particular graph. If you have all the different tasks, right, and they follow these dependencies, then it is actually the partial ordering among those tasks. Okay, so that is what we are trying to do. So we are trying to find the partial ordering among different tasks, right? So that is, each task may precede a subset of other tasks. So you can think of, so each and every task will have a preceding subset of tasks. Okay, so unless until those tasks are finished, so this task will not be started. Okay, so it is something like this. Okay, and some of these tasks may not have the precedence ordering. Okay, so that means they can be concurrently carried out. So those tasks are called as concurrent tasks. Okay, some of these tasks can be, they will not follow any, they have not follow, they are not going to follow any precedence ordering. Okay, that is not required. Okay, then so those tasks can be carried out concurrently. Okay, the dependency among activities are represented in the form of activity network. So we will talk about that. Okay, so a later point of time. So once the activity network has been worked out, the resources are allocated to each activity, right? So once that particular activity network representation has been worked out, okay, so thereafter we allocate the resources. Okay, so resource allocation is typically done using a Gantt chart. So we'll talk about the Gantt chart. So this Gantt chart will be usually helpful when you are allocating the resources. Okay, so after the resource allocation is done, so usually we will use a pie chart representation. Okay, that means a pie chart representation will be developed. So usually it is a project evaluation and review technique. Okay, by this technique we try to evaluate the project, and then you review the project, right, whether everything is going under are controlled or not, or whether we are making the progress as per what we thought before, right? Pet chart representation is useful to project managers to carry out project monitoring and control, right? So we'll talk about this work breakdown structure. So usually as part of this work breakdown structure, what do we try to do? So you recursively decompose the set of activities into smaller activities, okay? And then so you keep on decomposing them till we going into a fine level, okay? So you find a very basic unit of work, okay? And that can be allocated to the developer, or you can you can schedule also, okay? So once these project activities have been decomposed into a set of tasks using WBS, that means your work breakdown structure. Now the time frame when each activity is to be performed to be determined. Okay, so once that is decomposed, then you will have to say that by what time I'm start date and end date should be mentioned out. Okay, the end of each important activity is called as a milestone. That means, so that is one milestone you can say. Okay, so if you have finished that particular task, that means you have achieved that particular milestone. So now this will be actually helpful for for monitoring, project monitoring. Okay, so now this is the way by project managers tracks the progress of a particular project. Okay, if any of the milestones are not met, so in that case you need to take some corrective actions, right? Maybe you generate some information for the management, so as a result we try to carefully um, you know we try to carefully meet those meet that particular requirement by taking some corrective actions. Okay, so as part of this work breakdown structure, so we have certain notations, right? So each and every activity can be represented by a rectangle, and your root of the tree will represent the problem name. Okay, and these activities will be further divided into smaller sub activities. Okay, and we decompose those sub activities in such a way that we finally go to a very small unit of work, and that usually will take 1 or 2 weeks to execute. Okay. Finer subdivisions mean that a large amount of time must be spent on estimating and chart revision. Okay, so if you keep on dividing that particular activity to very small final level, that means maybe the task will take 1 or 2 days. In that case, what will happen? So actually, so dividing this will also takes more time, right? So so this dividing takes some planning, right? As well as also you need to see all these charts. Once one of these activities are finished, then you need to update the chart, right? Because you made a chart, right? You made a work breakdown structure, right? So you have to update that particular chart, right? So usually it involves more of the time, right? So the very best example here you can see is, so now compiler project, right? So let's say you wanted to represent this work breakdown structure of this compiler project. So what you want, you wanted to develop a compiler. Okay, so usually you can divide this large project. So the compiler project name is the root node. Okay, and the leaf nodes are this. For this particular root node is, these are the ones, like, so one is first requirements, then design, then code, then test, and then write manual. Okay, so that means these are the various important activities you divided, and now this coding activity is further divided into three. Like you wanted to develop lexer, you wanted to develop the parser for that particular compiler, you wanted to see the code generator. So now you can understand, now this whole work structure is actually broken into smaller work units, right? You keep on dividing them to till you achieve certain small unit of work. Okay, so today we'll stop at this work breakdown structure. Okay, we may continue in the next lecture. Okay, any doubts of our students? Any
No, sir.
doubt?
No, sir.
Okay.
No, sir.